Tak dobré dopoledne, dámy a pánové. Dovolte mi vás přivítat a otevřít dnešní úvodní dopolední sekci, která se věnuje oblasti správa infrastruktury. Dříve jsme tuto sekci nazývali pracovně utilitní a první příspěvek je věnován zástupci společnosti Esri. Velmi nás mrzí, že v letošním roce bohužel nemohl pan Pipper, který bude za chvilku hovořit, přijet osobně, protože současně v této době, v těchto dnech, probíhá paralelní mezinárodní konference IMGIS, Infrastructure Management and GIS konference v Americe, a alespoň nám natočil video osobně pro tuto konferenci. Výhodou je, že je alespoň titulkované, takže budete moci vnímat i v českém jazyce. Včera hovořil pan Petr Seidl o geografickém přístupu, Geographic approach, který teďka Esri se snaží nějakým způsobem propagovat, a o geografickém přístupu v oblasti správy inženýrských sítí nás seznámí právě následující videopříspěvek.
Hello and welcome everyone. Thank you for this opportunity to speak with you today and be part of this conference. My name is Matt Pipper and I'm the Global Industry Solutions Director for Utilities and AEC at Esri. It is my pleasure to be able to speak with you today on a topic that I'm very passionate about, applying the geographic approach for utilities. The purpose is to discuss some of the challenges facing utilities and how GIS and the geographic approach is creating modern utilities that are enabled by the power of location and geospatial thinking. As you are most likely aware, Esri provides solutions for managing many of the global issues currently being faced by organisations and communities. Things like climate change, unemployment, social equity, and overpopulation, and of course, most recently, the COVID-19 pandemic. But while it is recognised that utilities are required to adapt to these increasing challenges, it is also providing many new opportunities to innovate, adopt new technologies, and change and modernise your business processes. This business transformation is being driven by a few key drivers. When we look at these drivers for change, it can be simplified into three main areas. There are the known or the planned challenges. These are more of the traditional challenges that utilities have been trying to solve for many years. Things like ageing infrastructure, the ageing workforce, smart grid and IoT deployments, and the issues around OT and IT convergence, or even some of the more foundational issues like trying to improve your data quality. Next, I think there is the unknown or the unplanned challenges that utilities must react and adopt to. Things like emergency response and preparedness, which includes natural disaster events like wildfires, floods, earthquakes, and hurricanes. But there are also things like changing policies or regulations, or the commitments to things like the energy transition goals, or even the impacts due to the things like COVID-19. This unknown or forced work that is facing utilities used to equate to about 10% of the annual work. But what we are seeing is that many utilities are now having to scale up to 20 or 25% of their annual work, which is causing many challenges in resourcing and scheduling to deliver these work plans. And finally, the third trend I'm seeing is the rapid advancements in technologies that utilities are having to adapt and implement. The continued pressures to improve efficiencies, manage the modern grid, optimize your operations are resulting in many utilities looking for new solutions. And these solutions are here to help solve both the previous challenges, but also ensure they're set up for their future success. Now these days, most people would be familiar with the grid shown. We begin at the generation level and can see that the traditional power plant with some generating capacity coming from the renewable energies like solar and wind farms. At the generation network level, we see GIS being used to assist with things like site suitability, understanding where the best location to build green energy generation sites are based upon parameters like average temperature or wind zones. As we continue along, we see the transmission network taking the energy from the generation site to the substation. In the transmission network, GIS is used for design optimization and understanding network vulnerabilities. It is also used for things like vegetation management programs, from drone flight planning, reality capture, and advanced spatial analytics. Coming out of the zone substation, we are now into the distribution network, which includes numerous distributed energy resources. Utility customers are making green energy decisions like installing solar and battery or purchasing electric vehicles. And these implementations of these green energy solutions are changing the way a modern grid operates. You may not have realized it, but GIS is used across all the different tiers in the network and is applied to almost every workflow in every department, from asset management, operations management, network management, and project management. Let's take a look at some of the more common use cases of how GIS is used across a modern energy utility. Let's start by looking at asset management. GIS has long been an essential part of establishing asset management programs for utilities. Over the past few decades, with a constant need to do more with less resources, many utilities have strived to improve the efficiencies in these work plans. To do this though, it's not just a measure of potential failures or risk. To truly understand why an asset is failing and optimize these maintenance plans, you need to coordinate to where it is. For example, steel poles near the coastline are more prone to rust. Conductors in high wind corridors are more prone to clashing. And wood poles in fire zones are more prone to damage, but that same wood pole near water is more prone to rot. By understanding where your asset is and the surrounding environmental factors, you can greatly improve your maintenance and forecasting planning. By the use of a modern GIS, this has recently accelerated across many areas of your asset management programs. It is used to plan asset inspections, capture defects, and bring all the conditions together. And many utilities are using GIS to spatially visualize their current operational and capital investment plans, so they better understand how they are forecasting their programs of work and if there is conflict between their capital expenditure and operational expenditure plans. GIS is now going indoors, allowing full inspections of not only their office and corporate buildings, but also within their zone substations and plant facilities as well. This allows you to route to assets more efficiently, monitor the status of equipment in real time, but also perform things like space management and optimize your floor plans. And finally, one of the fastest adoption of GIS has come from the significant advancements in GIS technology to perform and optimize vegetation management. Vegetation management is one of the most expensive programs of work for utilities, which needs to keep the right-of-ways and corridors clear of vegetation. GIS now performs complete vegetation management solutions, from performing flight plans with the drones to capturing the imagery and LiDAR, storing it, managing it, and processing this data, then finally analyzing this data at a scale with machine and AI models. And solutions now can automate much of the work that was previously manual and done at the desktop level. As the adoption of GIS continues to grow beyond just design and mapping, we see GIS being used in more operational use cases. In the control room, operators are bringing in GIS data to improve their real-time decision-making. GIS is used to assist operators in scheduling and dispatch, knowing what is happening and where, providing accurate situation awareness. Bringing in these live data feeds, including weather patterns, traffic alerts, crew locations, in conjunction to where the equipment or the nearest isolation point is, can greatly assist in optimizing response times. Another significant benefit of a modern GIS is taking your GIS information to the field. ARCGIS provides a number of mobile applications designed to integrate complex data from enterprise systems and provide the capabilities to capture and edit data in a timely manner. Putting the right data in the hands of the field workers is essential to improving data quality and improving safety. With approximately 50% of utilities working in the field, the use of GIS to optimize routing, navigation, data capture when performing these inspections and maintenance creates a significant improvement in operation efficiencies. We discussed earlier that the grid we have today is not the same as it was when many of the technologies that are currently managing it were originally designed. To manage a modern network requires a modern network management system. The ARCGIS utility network is the next generation modern asset and network management technology from Esri, which was purposely built to take utilities forward on the digital transformation journey and meet the demands of today and tomorrow's grid. The utility network can be summarized into three main components. It has the most advanced network modeling on the market. The information model is robust and it's highly configurable, managing from the generation all the way down to the customer. It can also model across different tiers from your electric, your gas, your telecommunications, your water, and your district energy networks. The second point is it has the world-class integrated visualization and analytics. Out of the box, the utility network is 3D enabled, which allows organizations to bring to life their networks, creating interactive digital twin models of their networks and their assets. It is also possible to aggregate and report dynamically based on different event conditions, providing accurate and timely reporting for both current, historic, and future states. And finally, it has a modern services-based architecture and security, which allows you to control access and apply business rules to ensure your data and integrity is maintained in a secure manner, supporting both on-premise and on-cloud computing infrastructure. And this is really just the beginning. By implementing the utility network, it unlocks so many other capabilities in the ArcGIS platform that your organization may not be taking advantage of today. Things like 3D capabilities, digital twins for network and building information models, imagery and data capture, and the automation that comes from AI and machine learning. It solves the business challenges of today and meets the demands of the future and internet-connected systems needed for tomorrow's grid. One of the more innovating and exciting advancements in applying GIS is how it streamlines the project delivery lifecycle from design, build, operate, and maintain. One of the more common issues with utilities is the long backlog of the as-constructed designs that create significant delays in keeping essential systems up to date. GIS now provides solutions throughout all phases of project delivery and streamlines these workflows. It provides tools to capture the terrain, the environments, the building surrounds, and it integrates this into complex designs, which include building information models. Recently, Esri and Autodesk partnered to create a new product called GeoBIM, which streamlines and connects the workflows from BIM and GIS and put your projects and assets in spatial context in 3D. In addition, GIS now allows users to enhance your project tracking and progress with 4D and 5D, with the additions of time and cost integrated into simple to manage analytics and dashboards. It is now also possible to integrate with project planning systems to align project timelines and deliverables with detailed designs. And finally, GIS is breaking down the silos in project delivery by enabling the handoffs of all the stakeholders with access to information through sharing and collaboration, which improves not only the project transparency, but also reduces the duplication of work and prevents loss of data. Utilities are undergoing many challenges that require an understanding of modern technology capabilities. It requires a revised vision and strategy from both the business and the IT leadership, but most importantly perhaps is the changes needed to both the existing operating models and business processes to achieve this vision of what a modern utility is required to be in the future. To achieve this revised vision, location and GIS can add the greatest value by applying a geographic approach for utilities. A geographic approach is critical to addressing the life cycle of a modern utility, from the planning, design, to managing your assets and operations and delivering projects. It is a way of thinking and problem solving that integrates geographic science and information. From my experience, people just understand things better when they see it spatially. We inherently can comprehend and understand complex data sets with ease through geospatial thinking. This approach is already impacting you and your daily lives, and to transform a modern utility, we need to apply it to every department in your organization and every community in our society. The geographic approach is a framework for understanding and applying our knowledge for better understanding of social, economic, and environmental impacts. It organizes and integrates all factors, illuminating patterns and discovering new relationships. We are dealing with complex and sensitive data sets, which are not often owned by your utility. But these data sets need to be brought into our decision-making in all aspects of our work. This may require changes to many standard operating procedures that have been done the same way for many years. But moving forward, utilities must make and take these into consideration, how they are managing and operating in a manner to improve sustainability, resiliency, and equity. As more organisations adopt using environmental, social, and governance criteria to align their work with the United Nations Sustainable Development Goals, a geographic approach will be imperative to creating sustainable networks for energy, transportation, and telecommunications. With a geographic approach, decision makers can reduce the negative outcomes in the communities where they operate, including the harmful emissions, the loss of biodiversity, and other threats to our environment. GIS is already being used to understand where to place your green energy solutions at the generation level, but is also being used at the customer level through solar potential analysis and incentive programs. As more customers purchase electric vehicles, GIS is being used to assess the impacts to the grid and determine where these EV charging stations are required. GIS is also being used to monitor the ESG goals, providing the required data sets as part of the Living Atlas and the key indicators for the planet to track progress as a result of climate change. Around the world, we are seeing significant investments to modernise and make the grids of today more resilient. A modern energy utility grid needs to be resilient against many things. They need to be resilient against natural disasters that are happening at a higher frequency and ferocity than ever before. They need to be resilient to cyber attacks, which are at the highest ever levels with the rollout of much of the digital technologies we see today. And they need to be resilient to the impacts of what a modern grid will be, being able to adapt to the changes from large-scale electric vehicle adoptions, distributed energy resources, and other significant disruptive technologies. While not all potential threats in the network can actually be designed out, they can be prepared for so a utility can respond and recover faster, ensuring minimum disruptions. Communities must now have the capacity to mitigate risk and recover quickly. This resilience supports positive economic, social, and environmental outcomes. GIS technology enables leaders to visualize the impending threats and likely impacts on people, facilities, assets, and supply lanes. Then minimize these impacts to the employees, their customers, and the communities. Many communities are prioritizing the undeniable connection between essential utility services, transportation, energy, clean water. As such, equity is now a key consideration for infrastructure prioritization. Investment programs and grants are addressing the historical injustices and communities put at risk of economic disadvantage by infrastructure that has now been maintained or modernized. To determine and meet the energy demand, it will be imperative to consider each location in terms of its geographic conditions, the infrastructure design, and the energy resources. While utilities in many regions struggle to adopt more renewables, 13% of the global population still lacks access to electricity. Utility organisations are being challenged to design, build, and operate their networks in a way that considers the social, economic, and environmental well-being. To achieve this, GIS is being used to pinpoint where the greatest needs exist by including environmental and social equity parameters. It's being used to analyse plans and impacts which identify the demographic groups and the geographic locations which have higher vulnerability to environmental and public health stresses. And finally, it's being used to maintain the transparency to provide engagement to our communities. We are now seeing that many workflows are bringing equity analysis into their decision-making and planning. Utilities are asking the question, are our annual planned outages and capital programs done in an equitable way? When we restore power, is power restored in an equitable way? For many utilities, this is a challenge, but it is where ARCGIS is essential. It provides many layers of data from social justice, census, and diversity that can be integrated into your existing workflows to better understand these relationships. Utilities managing a modern grid cannot think about equity after the fact. It must be brought to the core in the business operations and decision-making frameworks. To implement a modern geographic approach requires a modern enterprise GIS. A modern enterprise GIS empowers the visualization and analysis of all relevant data in the specific context of location. And this is key to setting utilities' priorities. And one of the biggest shifts in thinking for many organizations that are advancing on their modern digital transformation projects is how the critical relationship exists between the ERP, the GIS, and the ADMS. A modern GIS is not just a design and mapping tool. The GIS works to provide additional value to bring together the ERP data sets from your assets, your inventory, your customers, and the ERP by using location to better assess the asset values and risk profiles. It optimizes your maintenance programs and streamlines mobility workflows for inspection programs, and it adheres to some of the best practice asset management standards. The GIS also acts as the bridge between the enterprise systems for the OT and IT convergence. The GIS can pass network and asset data through to the ADMS, as well as provide the control center operations with additional information feeds like weather, traffic, or these environmental layers. This information can assist when dispatching crews or prioritizing work. The GIS can also take the ADMS data and bring this back into your GIS and share it across the whole organization. It's pervasive. This means that the current operating state of the network can be shared throughout the organization to those that need it. This significantly improves your information latency. GIS plays a pivotal role bringing ERP systems together with ADMS, your SCADA systems, and other systems, creating business value while also reducing your integration costs. But a modern, comprehensive GIS goes beyond just the transactional data. It is designed to work with these enterprise systems and deliver solutions across your entire organization. And it does this in 3 ways. As discussed, it is your system of record. It connects your GIS and other systems of record to manage the transactions and the associated information governance. Then there is the system of insights, which really brings your data to life. It helps make better business decisions by utilizing things like advanced spatial analytics and other technologies like 3D, AI, and machine learning. And finally, we have the systems of engagement, which provide the ability for enterprise collaboration. Out of the box, users can control what they share, what other users can see, and also what users can do with this data once they have access to it. So, as a modern utility, what we must do is create a new generation of energy networks that are sustainable, equitable, easy to manage, and resilient against climate risks. In the short term, that means prioritizing where to repair and where to build anew. Long term, it means ensuring that critical assets can sustain a growing and migrating global population amid climate change, while expanding networks to serve more people equitably. Approaching the situation geographically means using data to understand where people and objects are in relation to each other and in relation to the built and natural systems. For all this to work, it requires organizations to think different. And often, the pathway to success is created by thinking spatial, enabled through a geographic approach. And with that, I'd like to thank you for your time, stay safe, and I hope to see you all soon. Thank you.
Tak měli jsme možnost slyšet příspěvek společnosti Esri, kterou podpořil naší konferenci, za to děkujeme. Slyšeli jste aspekty, které považuje společnost Esri za důležité v oblasti utilita, kterými chce dále vytvářet software a dodávat jej do naší uživatelské komunity. Pan Matt Pipper je dlouhá léta pracoval v energetické společnosti, takže vždycky diskuze s ním jsou poměrně inspirativní a zajímavé. A já doufám, že zase v budoucích letech se nám podaří získat zástupce Esri osobně sem k nám, abychom si případně s nimi mohli popovídat sami takto osobně.